Okay, so we've done the first page. Let's continue. Okay. So we have bromine, calcium, and cobalt, and they want me to place these in order of lowest to highest ionization energy. So I have my trend, so it's going to be lowest to highest. It's either going to be things on bottom or things most to the left. So I have bromine. I'm circling bromine and calcium and cobalt. Cobalt, calcium. So in terms of ionization energy, this is going to have the least. This is going to have the most. Now, what order do they want them in? Lowest to highest. Okay, so we want them. Calcium, cobalt, bromine. Ca, Co, Br. And why did I place them in this order? Well, again, how hard is it to pull something off over here as opposed to over here? So what I'm going to say is increasing number of protons, and I'm going to put in parentheses nuclear charge, because that's what I mean by increasing number of protons. Increasing nuclear charge increases ionization energy. Ionization energy. Okay, and then they're going to give me one that's in a row. Obviously, I'm discovering this trend diagonally. So we've got silver and fluorine and strontium. So silver, strontium, and fluorine. Well, fluorine has the highest ionization energy, so it's going to be FAGSR or SRAGF. I don't know what order we're going to want these in. Highest to lowest, so it's going to be FAG, silver, it's going to be fluorine, silver, and strontium. Why did I place them in this order? Now, I could just say these trends again. Increasing number of protons. Hopefully by now you understand this. Nuclear charge. Hopefully Dylan can stay awake while he's watching this exciting video. Increases ionization energy. Oh, by the way, hi Dylan if you happen to be watching this video. Increases ionization energy, increasing electron shielding, and I'm going to put shells / energy levels because it's all the same stuff, energy levels. Decreases ionization energy. Ionization energy. Okay, the most electronegative element on the periodic table. Oh, we're not even in the video here. There we go. So I just wrote all this stuff. Increasing electron shielding, shells, and energy levels. Because if I increase shells, I'm increasing electron shielding. Decreases ionization energy. And I've already explained why. The most electronegative element on the periodic table is fluorine. Now, I need you to remember that electronegativity is the desire or pull on electrons, how much it pulls to get a last electron. That's why noble gases aren't included in this. Fluorine is the most electronegative, even though the trend goes up and to the right. Noble gases all have 8 valence electrons, right? If it has 8 valence electrons, and if you don't have that labeled, valence electrons, 7, 6, 5, 4, 3, you should have that labeled so that you know the number of valence electrons. By now, I really need you to know, be able to look really quick, 3 valence electrons. Everything here has 3 valence electrons. But noble gases have 8, so they're not trying to get another one, so they're not pulling on anything. So they have 0 electronegativity. 0 electronegativity. That applies to just noble gases. It is therefore most reactive. As you go across the period, the electronegativity increases. We're still going across left to right. So I'm going to specify, because I can go across right to left too. As you go down the group on the periodic table, electronegativity decreases because of electron shielding. Okay, and then we got some more of these things to do. Place an order from greatest to least. Greatest to least. Okay, so potassium, selenium, oh my gosh, selenium, and zinc. So these are in a straight row across from each other, and we're going to do greatest to least. So it's going to be selenium, zinc, potassium. Selenium, zinc, potassium. Because the trend is up and to the right, so everything to the right has greater electronegativity than the thing to the left. Potassium, zinc, selenium. Why did I place them in this order? Well, let's get this back out. Increasing nuclear charge increases electronegativity until we get to the noble gases. So let's write it again. Increasing, and I'm going to stop doing the things in parentheses because by now you know. Increasing nuclear charge increases electronegativity until the noble gases. Oh, God. What am I doing? N-O-B-L-E, gases. Okay, least to greatest electronegativity, and I'm guessing that this is going to be things on top of each other. Polonium, sulfur, oxygen. Yes, it is. So we have oxygen, sulfur, polonium. So from least to greatest, polonium, sulfur, oxygen. Why did I place them in this order? Decreasing electron shielding increases electronegativity. God, that's a long word. I'm just going to make it go down the page like that. Okay, place the order. I'm guessing, but these are going to be diagonal to each other. So we have carbon, chlorine, and calcium. Chlorine, carbon, and calcium. Chlorine, carbon, and calcium. So it's a little bit left to right, mostly left to right. And they want them from greatest to least. So chlorine is going to have the most. Carbon is going to have the next most. And calcium way over there on the left is going to have the least. Why did I place them in this order? Okay, so it's a combination of these two things, right? Do I have to rewrite this again? It's just a combination. Decreasing electron shielding increases electronegativity. So from the bottom up, we get increasing nuclear charge increases electronegativity until we get to the noble gases. So from the bottom up, it's increasing. From the left to the right, it's increasing. So that's where that trend to the corner is. Okay. Let's get on to something where I don't have to answer the same questions over and over again. All right, oxygen. Lose or gain how many electrons? Well, oxygen is right here. It has 6 valence electrons, so it wants to gain 2. And its oxidation number is -2, because if I gain 2 negatively charged electrons, remember electrons are E minus, then I am -2. Is the ion bigger or smaller than the atom? Well, it's kind of like gaining weight. If I gain weight, I'm bigger. Family, oxygen, oxygen, family, or we can put the group, and that's 6A or 16. I will accept all answers. Oxygen family, 6A or 16. Oxygen is a non-metal. Oh, dang. Oh, wait. Oh, I have to go to my bit meeting. Oh, okay. So I'm going to stop this one right here, and I will continue on the next video in just a second. Okay? See y'all in a second.